before we start, let's do a couple of hands. Who uses Postgres? Okay, so that's the reason why you're here, I guess. Um, who only uses Postgres? Oh wow, one hand. Only Postgres, nothing else. No file database, plain files. People love that. Time series. Who has a time series use case or used time series or any kind of time series database before? Okay. What kind of time series database? Just scream it. Influx. Okay. Something else? Something else from Influx. Influx. Okay. Nothing else. All right. Who would consider Postgres to be a time series database? Well, where are all the hands hit? All right. So it seems like I have to do some convincing. Um, are there people that have no idea what time series are? All right, so at least a few people. So let's do a quick kind of get everyone up to the same level of knowledge, right? But before that, who am I? I'm Chris. I'm working for Timescale. Yes, we are a time series database built on Postgres. And we see that just a little bit at the end. I'm not here to sell Timescale to you. If you think it's worth it, you're gonna figure it out yourself. I worked at a couple of different companies in the past. Anyone who knows Ubisoft, ever heard of those? Before all the DRM problematics, right? I've been a long time with Hazacast, which was a distributed hash table and a distribution framework in general, making it able to, or making it simple for you to build an application that can run as multiple instances but still share state. I've been with Instana. We've been an observability tool, eventually being sold to IBM. That's when I left. And I had my own startup for about 3 years, one year full time. We unfortunately didn't get to the Series A. Well, we did get to the Series A, where we couldn't close it. So that's when we ran out of money. But we were using Timescale, and I think there's a reason why I'm here now. I really liked it. In general, I'm doing developer advocacy, which means I'm doing exactly what I'm doing right now for a living. I'm going to conferences, talking to people, trying to explain the technology and stuff like that, and why stuff is awesome, right? But I'm coming from a strong engineering background, mostly backend engineering, JIT compiler optimization, garbage collector optimization. Anyone who loves garbage collection optimization? Okay, 2 people at least. Normally, normally I say at an IT party, I'm the weird guy in the corner that nobody wants to talk to, right? Because when you have those kinds of things or love those kinds of things, people are like, oh, stay away from me. And I love fairy tales. And that's gonna be the last hands. Who believes AMD is faster than NVIDIA? Who believes NVIDIA is faster than AMD? Who believes Intel is crashing all of them? Nope, nope. Exactly. The benchmarks are always fairy tales, right? Don't believe in benchmarks. At least not in benchmarks anyone else did. Run your own benchmarks. That's my personal takeaway from anything I've done with benchmarks in the past. Yes, also Timescale publishes benchmarks. Please don't believe any of those. Do a benchmark with your own use case, your own data set, and see which one is the best solution to you. Especially with time series, it's a real issue. And if you want to find me on Mastodon or Twitter, that's me. So what is time series? As I said, we need to get a few people up to speed. So I think we're starting with the obvious things, right? It's financial transactions, anything that has some kind of a relation over time. You cannot pay if your bank account is empty, and that is obviously a relation between money in the bank and time, right? Same goes for anything stock market. I love to ask, like, what do you think what that is? What any guesses? It's a little bit older. It's from end of last year. Bitcoin, perfect. It got a little bit higher again, but I just love it. It's so beautiful. Um, any Bitcoin lovers here that I insulted? Oh, sorry. Um, yeah. Internet of Things, I think that is also pretty obvious, right? Anything like measurements, temperature, humidity, ammonia levels, but also geographical locations of cars, anything like that, right? The location of the car only makes sense when you see what path it took, because otherwise, what else, right? What gives? Um, Observability, as I said, I've been with Instana before, and who's using observability metrics? Or an observability tool, New Relic, Instana, what else? Huh? Dynatrace, right? That was the one I'm thinking about. So anything, or Prometheus Pure or whatever, right? Anything like that is obviously in a time relation, because otherwise it doesn't make sense. It's nice to know my CPU is at 99%, but it doesn't make sense if I don't have a time to that, because maybe it was okay. Maybe there was somebody buying 1 million iPhones on your online shop, right? That's perfectly fine if you expect it. Service traces are kind of the same thing, just a different way of presenting the different observability metrics, right? In this case, it's not about the speed, but it's about the connection between different services. And that is actually the system that I built at my own startup, a small startup, and it's still fairly complicated. We had a lot of services to do different things. In case you wonder, we measured animal barns, like the environmental information about animal barns and medication levels and stuff like that. We wanted to make the world a slightly better place. Not everything works. And that is my personal favorite, because it's not like super obvious. User tracking behavior, or tracking of user behavior. And Netflix is actually extremely open about it. That is taken from a presentation that is available on YouTube. And no matter how often I do this talk, I always forget to add the link for the next time. But it's super simple. If you go to YouTube and say Netflix and user analytics, you're going to find it. They're very open. And I mean, what is Netflix's whole purpose? To keep us on the platform as long as possible and understand what we want to watch, so they know where to invest next time, right? But it's not like super obvious that this would be a time series. But hey, guess what? If I drop out a second episode of a new season, and a lot of people do that, that only makes sense if they understand, oh, okay, so you watched the first one, you watched the first episode of the second season, you stopped somewhere in the second episode, so probably the second season is shit, right? That is the kind of stuff you want to understand. And just for the jokes, that's the Marvel timeline of all the Marvel movies. And yes, that is a total time series. I was shocked that there's so many movies. I'm not a Marvel fan. Any Marvel fans? Anyone shocked about the number? No? Okay, 2 at least. Oh, thank you. At least 2 people are shocked about it. I mean, I'm also not a DC fan, so I think I'm good to say I'm not a Marvel fan. Right. So to generalize that, I kind of hinted at that. It is normally when we do some observation over time of something, right? As I said, for example, a temperature only makes sense if you measure the temperature difference or change over time, right? It's nice to know it was 40 degrees, and that's probably pretty bad. But how long was it 40 degrees? There is actually rules about how long an animal is, well, can, by law, stay in or be surrounded by a certain amount of ammonia, or how long they can be under a certain temperature, right? And you have to prove those things, and that is obviously collecting those data. Same thing, it's nice to know that Bitcoin was $67,000. If it's not right now, that is beautiful information, but it doesn't help me, right? So it's always about the time. In terms of stocks, that is, we're talking about SQL here, right? Postgres. So in terms of stocks, it's a simple table. We have some timestamp somehow. We have a price, which is our measurement, and we have a symbol. And price should probably be a float, to be honest. But we have a symbol, which is the name of the stock. So we have some metadata. For something like a measurement, again, we have time, we have some metadata in terms of the device ID. We have some value of the sensor that we collected, and we have some additional information like a location or whatever. So in general, it's a time-related observation of something, of a subject. Good. With all the examples, who uses time series in his daily life? I know that it was more people that had their hands up when I asked for observability than when I asked for time series, right? But because that is all like, okay, time series, a few numbers or a few data points that you have to collect. So my personal favorite example is the New York Stock Exchange. And I need to read this number because I always forget it. So the New York Stock Exchange does 4.2 billion data points or transactions, like stock transactions per day, which is 160K per second. Yes, per second. 162,000 operations per second. I think that is a good deal. But it really becomes bad when you understand that they actually have to keep all those transactions for at least 5 years, which brings it up to 5.4 trillion. And since we are in Germany and inside of the European Union, who knows what the legal time would be in the European Union to keep those things? 10 years. So we're up to like, what is it? 10.8 trillion. That's a good number. I'd love to have a database of that size. The important question is, who believes he's working with big data now, right? That is something. Is it the biggest? I don't know, to be honest. But it's hard to find actual numbers, but those stock exchanges, they actually have to give those numbers away. So they're always good examples. So the question is, why would I store those things in Postgres? And we heard Influx. There's a couple of more. There's QuestDB. There is Prometheus, which is a time series database. There is Graphite. There is, what else? I don't know. I'm working on a list of all time series database, all active project time series databases that I can find, and I think I'm up to like 50 by now. Not all are like commercial products, obviously, but there is a lot of them. And the cool thing is, at least 20 of those claim to be the fastest time series database in the world. I love that. Seems to be some competition for that. That's why I'm not a big fan of doing performance comparisons. So, why Postgres? I've seen that most people here use Postgres. I think Postgres rocks, so why not? Anyone disagrees with that? No? Okay, so I can keep that away. You've never seen that, right? Nobody disagrees. All right. But there is a couple of hard facts. I think the biggest one is Postgres has an extremely established ecosystem. It's massive. There's extensions or tools for everything. And I know some people really would love to see HA and backups in the core, and I'm one of those. And we may eventually get there. But there's enough tools. There's something for every taste, right? If you say I don't like PG backrest, there's another backup tool. There's always an option. It's rock solid. It's around for, I don't know how long. I don't even know when the first version of Postgres came out. Anyone? No? Okay. So let's say it's far back in time. I think somewhere in the 90s or something. It's production proven. How many people use Postgres in production? There you go, right? I think we don't need to discuss that. It's SQL. If you love SQL or not, that's a different question. But how many people know at least a little bit of SQL, right? Exactly. It's basically everyone. How many know Flux? PromQL? Yep. Right? The number of hands is much less, and that's the important thing. Everyone knows SQL, at least to some certain extent. So everyone is able to do at least something, like getting some basic data, doing some calculation, doing some request of that. It's multi-model. I'm not sure if you really would love to do that, but there's extensions for GraphDBs, there's extensions for key value stores, there's extensions for almost anything in Postgres. And if you really want to, you can drop all of those in the same database and do joins on all those different data models, all on the same place, which can be interesting For production, there's things like foreign data wrapper. We've actually done that in the past, where you have like multiple Postgres instances. One is running basically the graph database, one is running timescale, one is running Postgres plain, and you just use the foreign data wrapper to connect all of those together, and you run the queries where they belong to. But you can do that, right? You can join between all of those. And obviously, elephants are cool, like Postgres is. So it's probably the best mascot ever. Maybe. Right. Anyway, you're a hard bunch. Nobody's laughing, like really hard. You're a hard bunch of people. So, oh, I actually fixed that one. Yes, it said sharing in the beginning for a couple of presentation times. So I managed to fix at least that. I probably did that during the presentation, so I don't forget. So the way to store that amount of data in Postgres, you want to do something like partitioning, like declarative partitioning. In the past, it was inheritance, and we see a couple of examples of that. Other people call it charting. I don't think we have a database administrator here or database person, like plain database, because they often start to cry when they see the word charting. It gives them like a really hard memory of the times where you actually had number ranges and you try to move them between different databases, and at some point it all broke apart, right? Or broke apart. We call it chunking. I think that was a really stupid move to do, but that was before my time, so what do I know, right? But it's the same thing. So whenever I say chunking, just switch it over in your head and say partitioning, full stop. So what does that mean? When we have a table of about 10 terabytes, we can do that in Postgres. Postgres would allow us to do that. It's probably not the fastest option to do. So even Postgres knew that very early. They added inheritance, so you could create child tables and split the data between different tables, right? So we're doing like 2.5 terabytes. We're just splitting it up by 4. We're doing like 2.5 terabytes, which is still pretty extensive, right? Postgres would probably be okay with that, but for a really speedy query, you want to go deeper. So you want to do something like a lot of 1 gigabyte, maybe 10 gigabyte partitions. Not saying chunks, partitions. And there's a couple of reasons why you want to do that. Or wait, that way around. So the way to do that in Postgres, there is 3 different options. You could say I want to have hash partitioning. Let's start with the most unintuitive ones. Hash partitioning means, hey, I have some key and I have a number of partitions, and what partition goes that key to, right? So you're basically taking a checksum of the key and use the modulo operator by the number of partitions, and for the same key you get the same partition every time. The problem with that is you have to understand how many partitions you want to have upfront. If anyone ever worked with Hazelcast or Cassandra or something, you know that because they ask you, like, how many partitions do you want? And you cannot change that number afterwards, because now your mathematical operation will not result in the same thing, or you would have to recalculate and distribute all the data. Very complicated. Postgres doesn't do that. Postgres tells you how many partitions. Good. There you go. List partitioning is a very interesting one. You can actually say for a specific key which partition it belongs to, which is interesting. So if you have like a massive customer that brings you billions of dollars or billions of euros, we're in Germany, billions of euros, you could say that customer gets its own partition. I do not want to see anyone else on that partition. And everyone else goes through the last, I don't know, 2 or 3. Very specific use case. I've never found a good use case in real life except for like this massive customer. At Ubisoft, we called them whale. It's a term that is generally used in the gaming industry. When you pay a lot for an online game, you're considered a whale. I don't know who came up with that term. I was kind of shocked when I heard this. Well, but hey, I mean, the Deutsche Bahn calls people Fleischgewicht, which is the meat weight. That's the official internal a train industry name for the passengers. And the first one is range partitioning. And you remember I said number ranges? That's exactly it. That is where the charting comes back. The only real good thing where this works is with time, right? Because time is only flowing forward, hopefully. I think nobody proved me wrong with that so far, at least none that I know about. And here is why you want to do that, right? There's 4 reasons, or 3 or 4, depending on how you see it. It's smaller tables. So that means when you have an execution plan, everyone knows what an execution plan is, right? Okay, for the ones that do not, when you send a query, the query is parsed, and the query planner tries to understand how do I run this best. So that's the execution plan. Even if the execution plan gives you a really shitty sequential scan, like going every single entry from front to back or from top to bottom, because the table is much smaller, it is faster. It may happen more often, but it's so fast that you normally don't realize. The more important thing is smaller indexes, and that is important. Smaller indexes means you can have a much faster update. The standard algorithm for indexing in Postgres is B-tree, and a B-tree update on a massive B-tree is extremely inefficient. So smaller indexes are very, very fast to update. Partition pruning is something which is really, really interesting. Partition pruning means the query planner understands what partitions are necessary to answer a question or to answer a query, right? So let's go back to the time example. I'm asking for January to, what is it, June, let's say May 2023. And I have like 100,000 of partitions or chunks. The query planner understands, okay, 99.9% of all partitions do not have any data for that query, so I don't even have to look at them. So partition pruning means throwing them out as fast as possible, best in the planning stage, so you don't even look at the data at all, which makes it much faster, because I don't know who ever tried to run a query with more than like 50 tables. That is not fun for the query planner. The number of mutations of possible answers to the question, what is best, becomes so big that the query planner just doesn't like it anymore. And when you have partitions, that can go very, very fast. We have people that have thousands of partitions, thousands of chunks in timescale terms. And they are okay, because nobody will ever call or ever ask for the whole range of data. If they do, well, that's probably not a good use case, right? And the last one is partition detaching. That is something which is extremely specific to Postgres, and I'm still trying to find a good use case for that. It means you can detach one of those partitions from the root table at any point in time. It's nice when you want to have data deleted quickly, so you detach it and it's not available for the queries anymore, so it looks like it's deleted, and then you'd say, okay, now delete it for real, and if that takes like 50 minutes, it doesn't matter. But the interesting thing is you can actually reattach a partition not only to the original root table, you can actually attach it to a different table as long as the schema matches. Somebody said that's great for backups. I tend to not agree with that. That's not a good backup strategy. I don't know why you would detach and then reattach something. But as I said, who am I to know, right? If anyone has a good use case for that, I'm happy to be enlightened. Okay, so let's do a couple of demos. And you remember I said we are running timescale at the very end. The only thing that is time. So one important thing. Oh wow. Let me see. It is so big and it still doesn't work. Font. Let's make it whatever. 26. I think that works. There you go. Oh, it doesn't change the rest of the UI, obviously. Is that okay, or should I switch to light? It's okay? Perfect. All right. So one thing, timescale. I'm not sure who was in the Yugerbyte presentation before that. Somebody asked, like, what does Postgres compatible means? And Frank's answer was like, we forked Postgres, or we forked parts of Postgres, and we have a different storage layer. For timescale, it's different. We are not Postgres compatible. We are an extension. That means you're running a plain vanilla Postgres. You install the extension, you're good to go. That means that you also have all the features of Postgres and all the development of Postgres, right? If you use Postgres 15, that's different from Postgres 12 because there was development as well. And I think that is important. So that means I'm using Timescale Cloud as a demo environment because it's easy to do, and it's sad that the rest of the UI isn't changing. Can I switch the size? I don't know. Probably not. Well, so anyway, we're starting simple. We started with the past, right? You remember the 10 terabyte table, so we just create a table which is called measurement, and it may be a little bit slow because I'm untethering. And even though we're in Germany, it's German mobile network, right? And I created a small insert statement that just generates a few data, and you see the original statement is a little bit older. So we generate at an interval of 10 seconds from June to August, to end of August 2022, we generate data, and we just generate some random reading, some random float. And it's not about time right now. As I said, I'm untethering, and the time doesn't tell us anything on German mobile networks. But it should go through. There you go. And we generated like roughly 790,000 rows, which is not bad, not great for 8 seconds. The important thing is, and we can actually run this right now for a first look, we see, yeah, it does a parallel sequential scan. When I run that, it takes 50 milliseconds. It's super simple to plan because there's only one table, so planning is ultra fast. Parallel sequential scan means that the query planner came up with the idea of saying, oh, cool, I can split that file and just run with multiple threads and trying to read it. Okay, can we do better? Yes, we can, right? We can add an index on the timestamp, and since we're asking for a specific timestamp, we can always say, cool, that must be faster. So let's rerun that, and we see, okay, planning takes about the same amount of time, but we're down to from 50 milliseconds to 4 milliseconds because we don't have to look at every single value for what I'm asking for, like 2 days in July. I don't have to look at June. I don't have to look at August. I just look at the index, and that's it. Okay, so that's the simple solution. That is what we do always with Postgres, right? Nothing special. So let's go a little bit more in depth, and let's delete the original table. Did it do that? Yes, it did. And we recreate it. Same way. We're looking at the old way of how you did partitioning in Postgres. And believe me, I'm happy I don't have to do this live in terms of live coding because I would not remember everything about that. So the original version of that was inheritance. And inheritance basically means create me a table as a child that looks exactly like my parent table, whatever that looks like, right? So it takes the schema of the parent table and does that. And I just create three child tables, June, July, August, nothing fancy here. It does that. Now is the horrible thing, because now I need to create a trigger and say, hey, whenever you want to insert something, please call me first because I want to redirect the original call, right? So we create a function which is insert trigger because I'm triggering on insert, and I say, hey, new is the magic keyword, like old in Postgres triggers, where you either have access to all the new values or the old values. So in this case, it is the new entry that I want to insert, and I say, hey, if you are in between these dates of June 1st and lower than July 1st, I want to redirect this insert to that specific table. If you are June to August, do that, and if you're early August to end of August, do that. And it's important to say, hey, if you gave me a timestamp somewhere outside of the valid range, that should throw an exception, because otherwise it will end up in the original table or it will be discarded altogether. It will actually, in this case, it will be discarded because I'm returning null, telling the original insert statement to not do anything. But okay, fair enough. If you can you imagine you have like more partitions because there's more month in a year, and there's more years in a century, and there's more years in a decade, and there's more decades in a century. And every single time you actually have to update this trigger. That was not beautiful. People hated that. And obviously we have to attach the trigger. So we say, hey, please trigger every single time before an insert on that specific table, and call my function. All right. That far, that is good. We do not create the indexes yet for the same reason. So we run the insert. And remember, for every single row, we are now running this trigger. And triggers do have overhead. It's not like massive overhead, but they do have overhead, and you can measure it. You can measure it. You remember it was like 9 seconds or something? There you go. And let's run the query again and see. What we see is, remember, we don't have an index. So we see 4 parallel scans. The interesting thing is that it looks at the 3 child tables plus the parent table, because maybe somebody forgot to return null or forgot to raise an exception, and the parent table may actually contain data. It's not beautiful, but it may happen. But we can do better. So that was 300 milliseconds, which sounds actually worse than it is. And query planning is about the same time. So let's create the indexes, and let's make this that operation fast. The interesting thing is now we see 3 index scans on the child tables, but because the original table, the parent table, doesn't have anything, it's still doing a sequential scan, which is instantaneous because there's nothing in it, right? Okay, so who thinks that is beautiful? Hopefully nobody. Oh, 2 people. You want to mock me? That's what you do. All right, and to be honest, the Postgres folks thought the same thing. That's horrible. Nobody's gonna do that. So they, after, I don't know, 4 years or something, they said, okay, we need to rework that and make it more usable. So they came up with declarative partitioning. So when we create the table now, what we say is, hey, please create me the table. The schema is the same, but we say we want to actually partition that as a range partitioning, using the timestamp, like the TS column. So we're creating a time series. Oops. And we do that. And what we have to do now is to create child tables, or partitions in this case, and say, hey, create me a table. It should be a partition of X, which gives me the schema. And then because I'm doing a range partitioning, I have to say, yeah, for that specific partition, that is the valid range. If it's not a timestamp, it could also be an integer, and it would be a customer ID or something like that. But again, you have to do the same thing. You have to create a partition for every single month. And you have to remember to do that up front. Yes? Can we have multiple partition keys? Not with that. With hash partitioning, you can. But what you can do, and I'm not 100% sure if you actually can do this underneath a range partition, but you can have, at least with hash partition, you can actually have child partitions of a partition. So you can slice the partition further down over time. It will not rearrange data, but it works. No, no. In this case, the root partition, the root table will never contain any data. So that's the difference, and I wanted to show that. In this case, the root table will never contain any data. The system will make sure that this is not going to happen. But when you, for example, a great use case for that would be something like storing invoices. guess what? Invoices have multiple dates. They, depending on how you store them, they either have a creation date or they have a payment date, which is probably 30 days in the future. So you have to remember to create those tables early, because otherwise, if you try to insert something, it's gonna fail, right? It's gonna tell you there's no partition for that. And we insert data again while this is talking. While this is taking a few seconds. It should be faster than the trigger because it's now internal to the system. There you go, right? It's about the same time as the original one, which is great. It makes it much faster and much more convenient to use. And you remember the partition pruning? I love that. Where the query planner understands like those partitions do not contain any data for whatever reason. And the only thing I can think of is debugging. You can actually switch that off. Great feature. You should totally not do that. But for the fun and the jokes and the laughs, we do it. And because we don't have indexes, we get the parallel sequential scan again. But what we see is there's only 3 of them, right? As I said, the root table can never contain any data, and the query planner knows that. So why would I look at that? Same thing. We create the index, and in this case, in case you realized, here we actually have to create the index on the child tables, right? So you not only have to create the table or create the inherited table, you don't only have to update the trigger, you also have to create the indexes, all of the indexes you ever created on all the other ones. So you have to understand or remember a lot of things. With the declarative partitioning, you create the index on the parent table, and all of the indexes are going to get inherited down, which is the only thing that makes sense, right? In the past, for inheritance, there's a few other use cases. It may actually be meaningful, but most of the time it's not. So if we create the index, it still happens what we expect, right? We see 3 index scans, still no fourth one. But the interesting thing, remember, we're still asking for 2 days in July. So why would we look at all those partitions? If we enable partition pruning, it happens exactly what should happen right from the start. It understands, oh, there's only one partition with data for those dates, so I can throw everything else away. With 3 partitions, that is not impressive. With like 100 or 1,000 partitions per month, that is. As I said, the query planner has a high issue or a large issue with a lot of different data. There you go. All right. So we are 7 minutes we have 7 minutes to go, and that works perfect because now we've seen what Postgres does for us, and the declarative partitioning is great. Don't get me wrong. But it gets better. You can do better. You can do more convenient. And that is the only part where timescale plays into the whole game. So timescale is older than declarative partitioning. We created that thing before the term partition became a thing in Postgres. That's why I said we call it chunk. Whatever. So it works kind of the same way. You create a standard table, and there is no partitioning statement because, as I said, partitioning didn't exist yet. But we have our magic function which says, hey, please transform that vanilla table into what we call a hypertable. And a hypertable is our term for the magic on top of all the partitions. We want to transform the measurements table, our time series column, and we're a time series database, so the only meaningful thing for us is a timestamp or an integer, which represents whatever. And we say, hey, we actually want to have partition sizes or chunk sizes of 1 month. So the rest works automatically, right? You do that, you're good, yoo-hoo. So it tells me I actually created a hypertable for you. The idea is 53. It lives in public measurements, or that's the name. And the true is, I don't know what the true means. But we're doing the same thing. We're inserting. We don't have to create partitions because we told timescale what the partition size should be. So it does that, and it runs. Come on. Do. And it doesn't use triggers. What we actually do, and I don't know, mobile network. What we actually do is we hook into the query planner. So when the query planner sees a hypertable, it calls us and says, hey, here's this hypertable. Please tell me what to do with that. And we look at the timestamps in the query, and we give back a number of partitions, basically the same thing as partition pruning does in plain Postgres. But what we do on the other hand, when you insert something, we're going ahead and say, oh, cool. So you need a few partitions that we don't know yet, because we don't have a partition for a specific date yet. Is it updating? Yeah. So we create those, and they should show up here in a second. There you go. Right, so it created those partitions for us automatically. And I can run that, and there is one other thing, right? So first of all, we automatically see there's some partition pruning going on, because there's still only one partition that actually holds data. But there's one other thing. It has an index scan right away, because why not? The only thing that makes sense for us to have by default is an index on the actual column that is our partitioning column, right? Anything else is stupid, or might be on top of that, but that is the main thing we need. So that is fun, and we did exactly what we did, and we did it in like a minute and a half or so. But we can go completely nuts. So I deleted the original table, or the previous table, and I recreated. And guess what? We're going a little bit nuts here. I don't want to do this with the declarative partitioning, because it's certainly not fun. But we say, hey, just create me a chunk per day. That's much cooler, right? That's depending on how many data you get per day, that may be something really valuable. We have people that sometimes have chunk size or partition sizes of just like 12 hours, because they have an ingest rate that is way too fast or way too big to keep larger chunks, because they go really, really quick into the multiple gigabytes. So now we created those, and if let's see if it's updating by itself, we should see, what is it, 90-ish partitions, something like that. 3 months, yeah, should be around 90-ish. While this is updating, I can actually execute the query again. And how many partitions should we see when we ask for July 14th to July 16th? I think I heard it. 3, exactly. We should see 3 of those. Okay, it did not update automatically, so let's do this on the side while we're looking at it. Actually, it's only 2. Huh? Exactly, it's less than 16. So it was close. No worries. I know, I know it is a little bit with the greater than or greater equals and lower than. But yes, we only looked at 2. And the interesting thing is, in this case, the chunks are so small that it decided looking at the index doesn't really give us anything. There's no benefit over just looking for a few numbers or a few rows. And that is something that is a thing to consider when choosing the chunk size. You want to have enough that the query planner thinks the index is actually worth looking at. But the interesting thing is, and now we have it, there is a lot more chunks now. And can you imagine you have to create all of those manually? Nah, right? Me neither. Okay, enough of timescale. Right? As I said, I'm not here to sell you timescale. If you see a value in the automatic management, because to be honest, Postgres did a big step forward with the declarative partitioning. What they're missing is the automatic management. If you think the automatic management is absolutely worth it, plus the other features that timescale has, like incrementally materialized views or compression, then timescale is for you. Otherwise, I think Postgres is great. As I said in the beginning, I don't think there's any reason to not use Postgres declarative partitioning, except for you want to have the additional convenience. But in general, because we're talking a little bit about time series, we have a few blog posts which I think are very valuable. What is time series data? Going a little bit deeper into like the specific of time series data and how they need to be in terms of relation and stuff like that. My unfortunately now previous colleague She was a great NFL fan, and the NFL, like most major sport leagues in the States, they offer a lot of data to analyze and to look at. And she took the NFL data and analyzed the heck out of it. So if you ever want to see how you take those like time series data and make sense out of it, that's your blog post to look at. And the other thing, when you have time series data, oftentimes you want to do analytics on that. And analytics is one thing, forecasting is the other, right? We remember the last 4 Black Fridays. So what is our prediction for the next Black Friday? Well, how big needs the system, or how far do we need to upgrade the system or increase the capacity, stuff like that. So the third one is about forecasting, and then there's the docs, right? You have to have the docs. And we have -1 minute for questions. But nobody stopped me yet, so who cares? Questions? Mm-hmm. No. So the question is the magic function create hypertable, if that is in the standard Postgres. No, it is provided by the extension. Like a lot of other things. So create hypertable is just one of those. As I said, we have compression, where you can say, okay, compress everything automatically older than 3 months. We have materialized views, which are incrementally updated. So you could say, hey, create a materialized view, and it will automatically understand, okay, that was the last timestamp I looked at when I materialized it. So I only need to rematerialize the next 1 hour or something. It's not this like all or nothing update. Did I get the red card? Oh, okay, okay, I can go. All right, don't tell me that. Anyone else? Yeah. Uh, right. So timescale will do that. So if you send an insert which has a timestamp in the year 2515, it will create a chunk for that specific time range. So what we do is we look at the chunk size, and we understand, oh, okay, so if you have 2 days, we have to do chunk size of 2 days. So we calculate what would be the first day for that specific chunk, and then we just drop it in. Which happened in my own startup. I actually had something in 2,300 something for whatever weird bug we ever had. I don't know, but we had some chunk in the future. I did not realize until I was looking at the latest date in the database, and I was like, why is that 2,300 something? With declarative partitioning, you have to create that partition up front, right? So that's always the thing. With the manual ways, you have to remember to actually do those things. Anyone else? Nope. Okay. Thank you very much.